Alright, so here's another application. Now this is a little bit more involved, so let's make sure we understand all the basic parts in this. Okay, so what you have is you have a bullet of mass m that is moving to the right with speed v, and this bullet is, let's call it v0. Okay, so it's moving to the right with speed v0. It's going to collide and get stuck to this block that is attached to a spring. It's initially, the block is at rest. Okay, so the first question is find speed of the block bullet right after the collision. The next one, we're going to figure out the maximum spring compression. Then we'll figure out the frequency of vibrations. And the last one is going to be maximum speed and maximum acceleration. Okay, so most of these parts, okay, you should be totally fine with. So once again, pause, answer part A, check part A, pause, B, check, pause, C, check, pause, D, check, whatever. Okay, so that's the order. So do it, just go through the process. Should be able to all answer part A. Part A should be a very standard answer, so make sure that you are able to do this. Alright, so here's the solution for part A. In part A, we have a perfectly inelastic collision, and we know that in such cases, Pi will be equal to Pf. Alright, so right at the collision, Pi is equal to Pf, because there's no forces acting on it right at the collision. The spring is not stretched, nothing's happening. The spring is in its equilibrium position, so right in the collision, nothing happens. Okay, we're going to assume that the collision happens just instantaneously. So in the beginning, we know that the mass is moving, so we have mv, the bullet is moving, the mass is at rest, and then at the end, they're both moving together, so it's mv0, so m plus m times v. Okay, so we know that m plus mv, and so this gives us v is equal to v0 divided by 2. Great, so we have this. Okay, now part B of the question is, what is the maximum spring compression? Okay, once again, stop, ask what concept will you use, and then go ahead and figure it out. So pause, wait, and wait for me to do it. Or no, pause, do it, check. So to find maximum compression, I'm going to use MEI equals MEF. In the beginning, the spring has no potential. All we have is the kinetic energy of the two systems. So we have half times 2m times v0 over 2 square. And at the end, all we have is potential energy for the system. So it is 1/2 kx square for the spring rather. So my x max, maximum compression, is going to be equal to, what is it? So half cancels out. There's a 2 here, and then there's a 4 here. So we get mv0 square over 2 times k. So check, make sure that you get do the algebra, and make sure that this is what you get, m times v0 square over 2a. Okay, so now that we have this is our maximum compression. Now part of the question is, what is the frequency of oscillations? Okay, so here's what we can think of it as. This problem is, if you look at the system, okay, what we have are the block bullet that are attached together, and then we have this. Alright, at any compression, let's say that this is where it all started. So at any compression, let's say if this is the equilibrium position, at any amount x, what we know is that the spring force Fs is equal to negative k times x. Okay, now what is the force of the spring? It is equal to the mass, force is equal to ma, so it is equal to 2 times ma, and this is the tricky thing here. Okay, keep in mind, because now the mass is not just m, it's 2 ma is equal to negative kx. Okay, which happens to be equal, so this gives us a is equal to negative k over 2m times x. Now as soon as you've written this out, okay, life is easy. Compare with a equals negative omega square x, and now once you make a comparison with this, then you see, identify omega, and once you know omega, then everything is very easy. So omega is going to be equal to square root of, there's no sign here, so omega is square root of k over 2m. Once you know my omega, we know f is equal to omega over 2 pi, which is 1 over 2 pi square root of k over 2m. And this is simply the expression for the simple harmonic motion for anything, okay, for the mass spring system. It is k over the mass, and in this case the mass happens to be 2 times m. So just keep that in mind. Don't just write it as k over m, because that's the common mistake that people make. Alright, we know the frequency. Let us now find the maximum speed and the maximum acceleration. Now if you remember from all your previous videos, the Vmax, okay, is equal to A, the amplitude, times omega, and A max is equal to A times omega squared. Okay, so let us combine all this. So A happens to be, we know the maximum compression. Okay, so A, because it starts with at its equilibrium position, the maximum compression is this X max, which is mv0 square over 2k. So it is going to be equal to mv0 square over 2k multiplied by omega, which is square root of k over 2m. Okay, so this is your maximum speed. Now the maximum acceleration is equal to A times omega square, where A again is mv0 square over 2k times omega square, which is k over 2m, and your acceleration ends up becoming equal to v0 square over 2. Actually, no, not 2, it's 4. Okay, I think I made a mistake somewhere. Oh, I know what I did. My x, oops, the x is square root of all this. That was my mistake. I'm sorry about that. I knew something seemed off. So my v, okay, v is square root of all this. Alright, so this makes sense now. So the k cancels out, m cancels out, and you get square root of v0 square over 4, okay, which is equal to v0 over 2, and this is exactly what we should be expecting for the maximum speed, because you see the speed that it started with is v02. Alright, so that's why I knew that something was off. Alright, good. I'm glad we was able to fix it right here. And once again here it is going to be, this is all square root. Okay, so let me fix this part. And so now this becomes equal to, there'll be a k in the numerator. You know what, we can just leave it this way. You can simplify it if you want to. Alright, so these are the expressions for the maximum speed and for the maximum acceleration. The key thing here to remember is that the omega, which will be equal to square root of k over the mass, just make sure that you adjust for the mass, and the mass is going to be twice the mass, because in the problem we've had 2 times the mass itself is not just m, it is 2 times m. So we need to make sure that we account for that. Okay, so that's it for this video. In the next one, we'll talk about the simple pendulum. What I'd like you to keep in mind is that for any mass spring system, you can immediately do this. If you know the mass and if you know the spring constant, omega is square root k over m, and from there on you can find the time period and the frequency very easily. You can find the velocity, find the acceleration, okay, and all those things. Alright, perfect.